Hello and welcome back to Invitation to Puzzles, where we have a killer puzzle by FullDeck and missing a few cards. They are quite prolific setters, and they have a lot of accessible puzzles. So I would encourage you to go to their website, which is linked in the description and as well in the puzzle. The puzzle's also linked in the description. If you want to check out more of their puzzles, and they're very carefully sorted by things like difficulty. I believe the ones I've been doing for this series are listed as mild. So if that sort of is the level you're looking for, they have a lot of puzzles listed as mild, or if you want to be spicier and go up in your spice tolerance, by all means, you can look at their higher stuff. But anyway, I recommend it to you. I think they have a lot of amazing puzzles up there. All right, so what are the rules of today's puzzle? Today's puzzle is a killer puzzle, and it's a killer puzzle that's all dominoes, by which I just mean that it's all two-cell cages. And what we're told about the cages is we're told the sum of the digits. So, for example, these add to 11, and so do these. That's probably why it is called 12 11s. Now, normally there's this bit about digits can't repeat in cages, which I mean, I guess is true, but here Sudoku itself tells you that, so it's not really adding much. So if you want to give the puzzle a go, by all means, click the link down in the description. But now I'm going to do it, so you can pause if you would like, and let's get started. All right, so in all killer puzzles, I like to start by just scanning for totals that I know there's only one way to do. And now I'll remind you, I have this little killer calculator here, so if I select this 3 and ask, it will tell me the ways to do it. You might not need this for two-cell killer cages, which is fine, but if you want, you can go under Advanced Settings and click Killer Calculator on if you don't have this over on your rule book. Or sorry, over on your rules. But anyway, that was all by way of saying that that cages that are two cells and sum to 3 have to be 1, 2. There is nothing else that they can be. Likewise, a cage... Oh, there's another one. It's right there. Likewise, a cage that sums to 4 is always 1, 3. Now, already you can see some Sudoku tumbling, because I've got this 1, 2 pair looking over at this digit. 1, 2 pair just meaning this is a 1 and a 2, so this can't be a 1. It would be too many 1s for the row. So that's a 3 and that's a 1. Looks back, so that's a 2 and that's a 1. There's also some big cages that are forced, so like this 17 cage, and I think there was another 17 cage. Those have to be 8 and 9. Those are the biggest you can make. Oh, this is another 1, 3. And in fact, actually, this 1, 3 is also sorted out by this 1, 2 down here. So that's the 3. That's the 1, which gives me that 2 and that 1. Now, those 1s conspire to place 1 in box 5 here. Now, there are about 6 other ways that you could have placed this 1 in box 5. So let me tell you 2 other ways that you could have placed the 1 in box 5, and then you can take advantage of all of these methods are useful at various different times. Here it's useful for me to go over a few different techniques because although any of them would have gotten you there here, different ones will be useful at different times. So first of all, one of the ways you could have placed a 1 here is to notice, even on the blank grid, I can't put a 1 in an 11 cage. Well, it would have to be 1 plus 10, right? And I don't have a 10. And while all of these cells are 11 cages, I have to put a 1 in box 5 somewhere. Where is it going to go? It's got to go there. That's one way. Another way to do it is to know that the sum of all the digits in a row, column, or box of a Sudoku puzzle is 45. And you know that the sum of these digits, if you add the cages together, is 44. That's 11 plus 11 plus 11 plus 11. Is 44, and so this cell has to make up the difference between 44 and 45, and therefore it's a 1. Okay. So take your pick of the various ways in which we have filled this 1 into this cell, and we will be happy about that. Let's see, are there any more places that we can place 1? Maybe not right away. I do see, though, that I now know what this 6 cage is. And basically, I'm just noticing I've got a ton of 1s. In fact, so many 1s that this 6 cage can't contain a 1. And so a 2-cell 6 cage has two options, and you can sort of think through this in your head. It's either 1 plus 5 or 2 plus 4, or you can click the button whichever you want. Well, it doesn't have a 1 in it, so it's not 1 plus 5, so this just is 2 plus 4, is what we have now concluded. Also, this 5 cage is getting very suspicious, because the biggest number you can possibly put in a 5 cage is a 4, and this digit sees a 1, 2, and 3, so it's at least 4. So that's a 4, and that's a 1, is what I am alleging to be the case. And that bunch of numbers is going to put a lot of pressure on what the 9 cage can be. So if you look at the 4 options, well, it's not that one. It's not 1, 8, because I don't have a 1. It's not 2, 7. And it's not 4, 5. So in fact, actually, you can fill in that this 9 cage is 3, 6. And this is quite often what you're going to do as you work through a killer puzzle, is you're going to slowly look at what the digits you're getting from step to step to step, what it is that they help with. Another thing I notice is that this 4, together with that 4, place 4 in box 7. Namely, 4 can't repeat in column 2, where we have a pair, or in column 3, where we already have an actual 4, and so the 4 has to go there, where it is joined by a 7. It has no choice. I need to make it sum to 11, so that is what that is. Okay. Did this 7 do something for me? And it means those aren't 4. I was trying to decide if that did something like place 4 in row 6 or something. I don't think so. But maybe, and I'm not noticing. Okay, so it is true that this 3, 6 cage here puts pressure on the 11 cages in the row, because I can't make this 11 cage with a 3 or with a 6. Sorry, with a 6. So it's either 2, 9 or 4, 7. Which isn't so exciting until you realize there's 2 11 cages that have to each be 2, 9 or 4, 7. And what that tells you is one of them is 2, 9 and one of them is 4, 7. So it actually tells you a lot about the set of digits in these 2 cages combined, even if it doesn't tell you that much about either of the cages individually. Also, we can keep our pencil marks clean, so this is a 7 or a 9, so this is a 2 or a 4, that's not a 2, so that's not a 9, that kind of business. But the real interesting thing it does, as far as I'm concerned, is that it lets me write in what digits are left in the row. Namely, we need a 1. We've got a 2. We've got a 3. We've got a 4, at least between the cages. We need a 5. We've got a 6. We've got a 7. We need an 8. And we've got a 9. So these numbers here are 1, 5, or 8. And that 8, 9 pair looks up at that cell. So this is a 1 or a 5. Okay, so this 6 cage, and here's another case where I'll show you 2 different ways to see that we know what the 6 cage is. One of them was for me to notice it was here before, and notice that I had 2 1s looking at it. So like the other 6 cage, it can't be 1, 5 anymore. It's 2, 4. What I actually saw is this cell's center marked as 1, 5, and therefore this cage can't be 1, 5, because that would be 3 1, 5s in the box. So either way, you get that this is 2, 4, and in fact, even better, we know the order, and so that's not a 4. And so that's not a 7. So we actually have a 2, 4 pair here in these cells. I also see now that I probably should contemplate what this 9 cage is, given that, and so you can see this a couple ways. One is, what do the 1, the 5, and the 8 go with? Well, the 1 and 8 go with each other. The 5 goes with a 4. That's a pretty big problem, because I just put a 4 there, so it's not that. Or you could just look at the 4 possibilities and see that I've ruled out 2, 3, and 4, and so therefore it has to be 1, 8. Either way, that makes you happy. You should go with what makes you happy. That is an 8, and that's a 1, and that's a 5, and that's an 8, and that's a 9, and that's an 8. We now get bouncing all around the world. Okay, and so these digits are a 7 and a 9 and a something. And the something is a 6. for the record. Okay, do I know anything about where the 8 goes in this box that I'm prepared to argue? I am prepared to argue it. So, yes, so in fact, actually, I was going to argue something about cages, but I don't even know how to do that if I actually just look at the 8 in the row and the 8 in these two columns. I, in fact, learned that this digit is an 8. So that's a 3. And now what about the 9 in this? Yeah, okay, so now I know where the 9 goes in this box. If I just look at that 8-9 pair looks down there, this 8-9 pair looks over, and you can't put a 9 in an 8 cage unless you're willing to put it with a -1, which would be strange. So therefore, that's a 9. That's a 2, I should probably fill in. That's not a 9 anymore. One of these two is a 9, and this 6 and 7, just for cleanliness, hygiene, will fill in. They go with a 4 and a 5 based on whichever one this happens to be. So what do we do with that? Well, this is not a 2-6 anymore, and this isn't a 2-6. Okay. So we are back to the same place we were in row 1, where there's 2 possible 8 cages that these could be, because they don't have a 2 in them. One of them is 1-7, one of them is 3-5. Well, there's also 2 8 cages, so these are a 1-7 and a 3-5, and you can actually just fill that in. And if I was super attentive, I would actually know which cage was which, because this one can't be the 3-5 cage, because that cell can't be 3 or 5. So in fact, if I was willing to put in the work, I would notice that this was the 1-7 and this isn't. And so in fact, I actually know where all those digits are. And so now I know what that is and what that is. What that is. And that has given me the 2 and the 1 over there. Okay, so what are these digits now? The things that are left in this box. They seem to be a 4, which has to go there. The 6, which has to go there. And now this column is almost done. I think it's missing a 3. This column is almost done. It's probably not missing a 3. It seems missing a 7. And this pair is a 4-6. I don't think I know the order. I think it's just 4-6. Okay. It's probably worth marking this box up a little bit. So, like, this box needs to have a 7 in it. Oh, never mind. Sorry. Here's a much easier place. This box needs to have an 8 in it. Where is it going? It's going in one of these 3 cells. But which one of those 3 is it actually going in? Well, not these 2, because 8 goes with a 3 in an 11 cage, and there's already a 3 in the column. So in fact, this is the 8 and the 3, which makes that the 9 and the 8. Okay, so 7 definitely goes in one of these, and it goes with a 4, but I don't think I know, unless I want to argue something about an X-Wing. Sure, I'll argue about a Z-Wing. Why not? So one of these 2 is a 7 just by Sudoku, which means one of these is a 4 just by Sudoku. Okay, this creates that Z-Wing pattern I sometimes talk about, where the 4 is in box 2, are in one of these 2 cells, and the 4 is in box 5 are in one of these 2 cells. And so the Z-Wing question is, well, if that's the case, where's the 4 in column 5? And that means it has to be in one of these cells. Well, it's not that one, because there's a 4 already in the row. So in fact, we can sort of in a very weird way place this 4 down here, because we know a little bit about what's going on in this box, and that's enough to place this 4 over down here. Okay, let's fill in this triple, because I suspect we'll be able to sort out what the 11 cage is if we fill in this triple. 3, 4, let's see. So we've got a 5, 6, and 9. Okay, well, 9 is not going in this 11 cage because 9 goes with 2. So 9 is going there for what it is worth. 9's not going there either. Okay, I thought that was going to be more useful than it turned out to be, is I think the answer to the question. Oh, where's 2 going in this box? That is a useful question. 2 in this box by Sudoku is going there now, which makes that a 4 and a 7. which makes that a 2 and a 9. Makes that a 9. And now we've placed our 4, so we've placed our 7. 6 and 4. 2 and 4 over there. This 14 cage is now forced, because 14 cages are always either 5-9 or 6-8. There's two possibilities, but it's not 5-9 anymore, so it's 6-8. And we actually even know the order, thanks to Sven. So that sorts out that. And this is now a naked single 7. Oh, we've even sorted out that now. Let's see. This is a pair of 6 and 8. Looks like. Oh, this is a single of a 5 for the row. These two are 3 and 9. So that's an 8 to make the cage total work. Okay, this is known by the row, and it's going to give us a lot more sort of digits. So we've got, this is a 5, so that's a 6. So these are our 2 and our 9, just to fill out the box. Let's see what's going on in this column. We've got a 7 and a 9, so that's a 7 and that's a 9. Makes that a 6, just to fill out my 13 cage. And now we've only got a few digits left in the entire grid to fill in. So we've got our 1, 2, 3, 4. We need a 5 and a 7 in here. This column looks like it needs a 2. I was wrong. Let's try again. It looks like it needs a 5. There we go. This row now looks like it needs a 7. This is a 5, and that's a 3. Very nice. I hope you enjoyed this little detour. Let me know if you learned anything in here. I've been trying to sort of mix in some of the slightly fancier techniques, even when I suspect they're not necessary, just to sort of broaden your view of how you can think about these things in Sudoku. Let me know if you like that, or if you would rather I try and like stick to the bare minimum for these as far as making these approachable and friendly. But that's going to be all for today's episode. Do please, again, leave a comment, preferably a nice comment, and a thumbs up, a subscription, a donation, maybe, huh? But that's all for today's episode. I'll see you soon. Bye for now.